everyone. It's another time of external examination in the year 2024, and this is NECO Chemistry Practical 2024. Okay, I want to welcome everybody back to my YouTube channel where I will present to you outstanding chemistry, okay, with a great understanding because the channel is an outstanding channel. My fellow chemists, my students, you're welcome back to this channel. Okay, now I want to sincerely appreciate my viewers, the people that subscribe to my channel. For alternative B, I'm so grateful for people that subscribe, people that view my channel. God bless you so much. The first question, I treated 7 questions from that particular video, and the first question came out. First question came out exactly like that for alternative B. So grateful to God, and keep watching this channel, keep subscribing, and let's stay tuned. Let's quickly dive in and see what you have in store for us today. Today is we're going to be looking at NECO chemistry practical, but for today I'm going to be basing my teaching on titration. Okay, for this NECO 2024, we are given an acid which is H2SO4 as of a 6 acid, and we are given 3.8 cm, okay, to be dissolved in 1000 cm cube of water. And our base for this NECO is Na2CO3. This one is 6 gram per dm3. Of course, we're going to dissolve it in also water, okay, depending on your number of students, but that's the standard of the solution, right? But for this experiment, since it's not a real life practical, so I'm going to be using a calculated value that I've solved here, that I've calculated here to arrive at all my answers now. So let's look at how to calculate a titer value, call it calculated value, using the dilution factor, using our C1, V1, C2, V2. Okay, C1 of H2SO4 stock preparation is 18 mole per dm3. Okay, I told you earlier, this referred to the chemistry practical by Dr. Jokuku Godwin. Okay, everything is there, and your V1 is the given value that the NECO give in yellow paper. Your C2 is what we are looking for, and our V2 is 1 dm3, which is also 1000 cm3. So when we substitute this value, we are going to arrive finally at 0.0684 mole per dm3 of the acid. All right, this is our answer. This is the conc of acid now, because we want to get our volume of acid, because we are not calculating it in the lab now. So the base is Na2CO3. I'm going to calculate my molar mass to the 3 times 2 plus 12 plus 16 times 3, everything giving us 106 gram per mole. So if I use my formula, so I'm going to have this. Okay, this is the value given for base in gram per dm3. I'm converting to mole per dm3 by dividing by 1000. By dividing by 106, I beg your pardon. So I'm going to have 0.0566 mole per dm3. Remember, it must be what? 3 significant figure. Anytime you are dealing with mole per dm3, remember, anytime you are dealing with molar mass, it must be what? Gram per mole. That's the standard. Okay. Now let's move to equation of the reaction. So this equation of the reaction, acid plus this base giving us this with liberation of CO2, 1:1. Right. If I use this formula, I'm going to have my Ca, which is what I derive from up, my Vs1 I'm looking for, my Cb, so I just derive it from up, from the given value. This Vb is the volume of the pipette I'm using for this particular experiment. All right, some school use 20. All right, I have from the calculated equation you can see 1 mole of acid here, 1 mole of acid, all right, and 1 mole of what, of base. That's what I have. So when I use this equation, I'm going to have, I substitute correctly, the value of my acid now will be 20.70 cm3. So for this calculation, for this experiment, for all my solving for today in this particular video, I'm going to be using 20.70. Now, this aspect I just calculated is majorly for a tutor. If you're a teacher or if you're a tutor, this is, you need this. You actually need to know how to go about this. But if you are a student, don't bother about it. Please don't bother about it. As a student, just go straight to titration calculations, and that's what we'll begin now. Okay, I have some samples of questions that we can quickly talk about. Okay, then colleagues, let's come closer. Let's dive in and see what we have in store for us. Let's calculate together. Now, a question here says, number one, A, my acid contains a concentration of 0.05 mole per dmq of of a 6 acid, and the B is an anhydrous sodium trioxocarbonates 4. Okay, that's what we have. So let's now look at the question. Say put A into the burette and titrate against 20 or 25 portion of B using methyl orange as my indicator. Repeat titration to obtain constant titer. Tabulate your burette readings and calculate the average volume of A used. Remember, it's a sample of questions. So let's now look at, after that, the equation of the reaction is this. Then we arrive at this table. Now, there are certain things I need to discuss when it comes to table, because I used to tell my students that table is supposed to be a free of charge 10 mark. 10 mark, which is what? Free of charge. 10 marks free of charge. Now, I have this here. I'm going to be using 20.7 and 20.7. All right. Now, these two together now, I'm going to have this 20.7 plus 20.7, the final value 20.7. Now, it's very important for me or for any student to understand this, that in selecting your value of acid, there must be concurrent. 20.7, 20.7. We call it concordant values in chemistry. We call it what? Concordant values. Okay. If for instance I've selected 20.21.0 and 20.7, that's 0.3 difference. 0.3 difference. 0.3 difference. 0.3 difference is, which is, it is higher. It is higher. Okay, it will reduce your marks. So let's go to the question. One of the questions that I'm supposed to calculate is, from the result and the information provided above, calculate, number one, the concentration of B in mole per dmq. Number two, calculate the mass of sodium nitrate 6 that will be formed in the solution if 1 dmq or solution B were neutralized by solution A. And the next question says, calculate the volume of CO2 at what? At STP that will be liberated. So let's quickly dive into the solution. Concentration of B in mole per dmq. Okay, using our Cavana. Okay, from this, I need to let us know how YNECO NECO marks. This particular expression, okay, will give you 1 mark. Now, this correct substitution, this is the value of your Ca given, and these are value of the acid, the calculated value. We're going to conk of B in mole per dmq times the volume of the acid, the volume of the pipette I'm using. Alright. So I have volume conc of B mole per DMQ. You now give me this multiplied by this times this, then I have this, and at the end of the day I have 0.0414 mole per DMQ of B. Remember my B is Na2CO3. I'm done with that. Now I need to calculate the mass of sodium tetrasulfate that will be formed in the solution. Please pay attention and work with me. Now, in my relationship, what I want to do, I want to relate my reactant to my product. But you know, my value that I have is in mole per DMQ. So I'm going to convert that value to moles. So I employ this formula: number of mole conc of B mole per DMQ times volume in CMQ over 1000. I can use that, or make use of my conc of B in mole per DMQ. That's 0.04114 multiplied by 1000, which is 1 DMQ. Okay, giving, can you see the 1 DMQ here, which is equals to 1000 CMQ. Right, divided by 1000 from the formula give us 0.041 moles. This is now moles of B. So I can go back to my equation now and use it. Now, but I need to calculate the mass of Na2SO4. In calculating that, 23 times 2, that's 46, plus 32 plus 16 times, so everything gives us what? 142. Okay, 142. All right, let's use that. Now, from the balanced equation, let's use this. The balanced equation: 1 mole of Na2CO3. You know, the ratio of sodium carbonate there is 1 mole. So the mass of this guy give us what? 142 gram. All right. Now 0.0414 moles converted there. Okay, equals to what? X. So when we multiply it, we have what? 5.88 grams. About 88 grams. But that's our answer, 5.88 grams. I hope you are following. Good. Now, so let's check the next answer. Volume of carbon dioxide liberated at STP that will be liberated in the above equation. So from the equation, you already know that 1 mole of this one give us this. So you can also relate mole now to what? To volume. So it's a stoichiometric calculation. Mole to what? To volume. So 0.04 moles to what? To X. So when we do that, we have this and we have this 0.93 DMQ. And when you convert to CMQ, that multiplied by 1000 will give us 927.36. Remember, 1 DMQ is equal to 1000 CMQ. Alternatively, if you want to go by mole, you can also go by the mass. You can say 142 gram of I beg your pardon. You can go by 142 gram of this one supposed to be Na2SO4 that give us this. All right, and the same thing, Na2SO4. You know, Na2SO4 5.88 gotten from up will now give us X. So when we multiply that, 5.88 multiplied by 22.4 DMQ divided by 142, we get the same answer. So any of the method can still work for us to get the same answer. It's a stoichiometry reaction. So let's quickly dive to number 2. Number 2. Now, A is a solution of H2SO4 containing 3.8 gram per DMQ. B is a solution containing sodium trioxocarbonates. All right, we have been given the molar mass of what? Of Na of H2SO4. Now, this is the equation of the reaction. We know that now. So from the result, we just make use of the table that we have before. Okay, we don't need to be repeating that because the calculated value we are using. So we are calculating cohesion of A mole per DMQ, of B mole per DMQ, of B in gram per DMQ. It's a straightforward questions that any student going for exam should know. So let's use this formula. So we are given 3.8. 3.8 divided by 98 gram per mole of H2SO4 will give us 0.0388 mole per DMQ. We are done with this. So let's move to the second one. Cohesion of B in mole per DMQ. So we are using our Kaval. Using our Kaval, remember I told you this expression is 1. The expression for substitution is also 1, correct substitution. The expression for change of formula is also 1. And the final answer is also 1. Now, when you notice all my calculation, there are always 2, 3 significant figure. That's the standard for you to score. Please, students, you are watching, take note. For you to score under mole per DMQ, will be 3 significant figures. See there. And as a tutor, remember to tell your students, remember to teach them that they must always make their mole per DMQ as well 3 significant figures. So when you substitute the value, everything you have 0.0321 of B. Remember, now this B now we need to take them to gram per what? Per DMQ. Convert this one. The formula we need is concentration in gram per DMQ over what? Molar mass. So we already have our mole per DMQ, which is this. So let's go with it. So this multiplied by 106, giving us our final answer is what? 3.40 gram per DMQ. 3.40 gram per DMQ. Good. I think we are moving forward. Hope you are getting it. Okay, just follow it closely. You will get it. Titration is very sweet. I love doing it. It's my practical is one of my strength. Now, number 3 is solution. A is a solution of H2SO4. That's what we're giving. While B is a solution of Na2CO2 containing 1.00 gram in 250 cm cube. Alright. Now, the equation of the reaction remains this. Please take note. You can ask to write a balanced chemical equation. So that's the way it happened in alternative B. Some of you that search alternative B, they asked us to write a balanced chemical equation, and we did. Okay, let's calculate the cohesion of B mole per DMQ, and of A in mole per DMQ, and of A in gram per DMQ. Kind of repetition, but this question is unique because there are some things we need to quickly convert. Now let's look at, we are given 1. This one is given in gram in 250, not per DMQ. So we cannot substitute it here. We are going to convert it standard to what? To gram per DMQ, which is a standard unit. That's why we go through all these processes. Now we have this. The molar mass was not given, but we are giving the values for each of the elements. Now, sodium 23 times 2 plus 12 plus 16 times 3, 106. So we can actually divide our 4 gram per DMQ divided by what? 106, giving us 0.0377 mole per DMQ. Also to 3 significant because we are done with that. Number 2, cohesion of A in mole per DMQ. Calculated B mole per DMQ, so we can make use of what? Of our Kaval. Okay, Kaval, remember 1 mark expression. Please, students, follow this lead so that the person marking your script can actually see the legibility and give you your full mark. I beg you. Okay. All right. So I'm looking for conc of A. You multiply by this, substitute the values. Then all in all, you have 0.0455 mole per DMQ. Convert this one to gram per DMQ. Then the value of molar mass 1 times 2. Hydrogen is 1, 2 of it. Sulfur there 32. Oxygen 16 times 4, everything 98 gram per mole. Remember your units, very, very important. Then you use your formula, conc gram per DMQ over molar mass. Then you have your final answer. Oh, you have gone far. You have gone far. I hope you are following. I hope you are digesting it slowly. Okay. Don't worry. You will pass NECO exam. Okay. by special grace of God. We're almost getting to the end of the class. Let's look at number 4. This number 4 is, the student need to pay absolute attention. A is 0.100 mole per dm solution of an acid, while B is a solution of Na2CO3 containing 4.25 gram per 500 cm3. Now, in this question, I don't know the acid, I don't know the base. I don't have any equation. So even though you have the knowledge that your acid is H2SO4, the base is Na2CO3, you cannot balance the equation here because nobody inform you that it's H2 SO4. It just says an acid. An acid can be HCl, H2SO4, HNO3, CH3, COOH, like that. Okay, but for this, categorically it said that what? That is an acid, but it was not mentioned. So let's look at what we are expected to do. Now we are calculating number of moles of acid in average theta, number of mole of base in negative theta of B in the volume of B, and mole ratio of acid to base in the reaction. I love chemistry. Chemistry is so fun. All right, let's look at the solution. The formula to use for number of mole is conc in mole per dm³ times volume over 1000. So my conc given is 0.100 times volume of the acid 20.7 over 1000. This one give me 0.0020 moles. Please pay attention. This is of A. Please pay attention. This is of A. Now, what I'm giving now, I'm giving 4.25 gram per 500. It's not in gram per dm³. It's not in mole per dm, and I need my value in mole per dm³. So I'm going to convert this to gram per dm³, then take it to mole per dm³. You see? So let's follow the conversion process. You can see it. Then we arrive at this as gram per dm³. But this is not what we are going to use because the formula need mole per dm³. So I'm going to calculate my molar mass again. Na2CO3 give me 106 gram per mole. Then I'm bringing it down to this formula, conking gram per dm³ over molar mass. When I do that, I have 0.0802 mole per dm³. That's what I have. Now I cannot use this for calculation. I can use this for calculation. I have what? 0.0802 times 25. 25 is what I use for my pipettes, my base. In your school, if you are using 20, you put 20 there. So divide by 1000, give me 0.0201 mole of B. I've answered question 1, question 2. Question 3 is a mole ratio of acid to base. Okay, so you guys, for my acid is 0.0201, for my base 0.00201. First one is 0.0207, ratio 0.0201. So how do I get my final answer? I'm going to divide both sides by the smallest. The smallest is 0.00201. 0.00201 divided by the smallest, you have this, you have this. So you have 1:1. Invariably, the question is telling you that from the knowledge of the acid that you know, that is H2SO4 reacting with trioxocarbonates, when you look at the acid ratio base, it's 1:1. Did you catch it? Oh, chemistry is so fun. Alright, number 5. We are getting closer to the end. So today, stay tuned, stay tuned. Please don't go away. Now, A is a solution of H2SO4 containing 5 gram per dm³. This time around we are going to, I'm saying impure. Wow, impure. Oh, how would I answer this kind of question? Oh, wow. Let me teach you. Let's go there. Now look at my balanced chemical equation 1:1. See, let's look at the question. What was the question of A in mole per dm³, conc of B in mole per dm³, and percentage purity of Na2CO3. Wow. How would I do that? Dive in. Let's calculate conc of A first. We are given in gram per dm³, which is 5. Okay, so you calculate the molar mass to be 98 gram per mole. So divide by molar mass, you have 0.05 0.510 mole per dmq of A. Remember, of what? A, or acid. Now base, now you're going to use kava because of you have already have your A mole per dmq. So use kava. In using kava, you're going to have this as our equation 1 mark. I told you this is also 1 mark, and for correct substitution 1 mark, for subject formula also 1 mark. Final answer is also what? 1 mark. 0.0422 mole per dmq of what? Of B. Of B. Okay. Alright, lastly, then we have to calculate percentage purity. Now look at something important. Here we are giving the impure value to be 7.3. Okay, and our formula for calculating percentage purity, okay, is pure over impure times 100. Now look at the method there. Your pure in gram per dmq divided by your impure in gram per dmq times 100. That's a method you can use. So, but now you have your pure to be a mole per dmq. So I'm going to convert it, and you use this formula in converting that. Okay, you are looking for gram per dmq. Our molar mass is 106 multiplied by our value 0.042. You can see there. So you have 4.47 gram per dmq. That's what we have. Okay, 4.7 gram per dmq. Now, remember, your pure must not be more than your impure, or else you will not get correct answer. You'll be getting above 100%. So 4.47 divided by what? Divided by 3, divided by 7.3, multiplied by what? 100, give you 61.2. Alternatively, if you do want to convert 0.0422, then you can convert the impure, this impure, to mole per dmq. So when you do that, so it now be mole per dmq, here over mole per dmq multiplied by 100. You still get the same answer. Alright, second to the last question as we close for this titration, because I know A is sure when you follow this step given in this particular video, of course you get A. Another aspect, A is a solution containing 0.0262 mole per dmq of H2SO4, while B is 5.6 impure. Again, we are giving an impure, but let's see if the question will be the same or the question will be different. All right, now say concentration of B in mole per dmq, concentration of what? B in gram per dmq. All right, now percentage impurity of Na2 in B. The first one, question number 5, talk about percentage purity. This one is talking about percentage impurity. Alright, let's see the method to use. Let's use kava first, because you are looking for conc of B mole per dmq. We already have conc of A mole per dmq. So when we substitute, we will have this 0.0217 mole per dmq of B. Okay, this one is of B. Then we can calculate, change this one to what? 2 gram per dmq, because our molar mass can also be calculated like this. Okay, so when we multiply now, you have this value 0.0217 multiplied by 106 give us 2.3. This 2.3 now is our pure. Okay, is our what? Is our pure substance, right? Because it's an experiment that was being performed by you. You are sure what you are doing. Now look at the formula. Percentage purity is equals to what? Impure minus pure over impure times what? 100. These are pure, and our impure has been given to be what? To be 5.6. Let's go and get it. Impure been given to what? 5.6. So going back to that question, we have 5.6 minus 2.3 divided by 5.6 multiplied by 100, which will give us what? 58.9. 58. Fine, I hope you get that. Okay, if they ask you here to calculate particle purity, you don't need to even write formula, just say 100 minus impurity gives what? Purity. Okay, lastly, under this titration, among other questions, let's look at the last question. A is a solution of containing 6.22 gram of an acid. The acid now is H2Y. You don't know whether it's H2Y SO4. Don't know why it's H2SO4. We don't know what that is, but it say H2Y. B contains 5.7 gram of Na2CO3 per dmq of the solution. All right. Look at the balanced chemical equation given. Also 1:1. All right. Say from the equation and from the information provided above, calculate concentration of B in mole per dmq, concentration of A in mole per dmq, and the molar mass of H2Y. So let's see this formula for conc of B in mole per dmq. It's supposed to be conc of B in mole per dmq. That's the first thing we are calculating. So if you are doing that, see what we have here. Okay, to calculate conc of B in mole per dmq. Okay, you have this formula. You calculate your molar mass to be 106, and you divide your molar mass with 5.7, which is the value of B given. Let's check value of B given. Can you see it there? Then at the end of the day, you have 0.0538 mole per dmq. Now you have to calculate the conc of A in mole per dmq. So let's do that. So conc of A in mole per dmq is now using Kavar. When you use Kavar, you're going to have 1:1. Substitute conc of A is 20.70 divided by 0.0538 multiplied by 25. Everything is giving us what? 0.0650 of A. Remember, of A. All right. Now, molar mass of H2Y, which is our A. Okay. Remember, you are given the value of A in gram per dmq was 6.22, and you have the value in mole per dmq to be 0.650. Just divide it, making your molar mass of the formula. Then you have 95.69 gram per mole. This is equal to 96. Now let's look at something. Now, if we are to assume Y will be SO4. Now, when you look at SO4, S molar mass is 32, all right, plus oxygen is 16 times what? How many oxygen can you see? You can see 4 oxygen here. So you're going to have 32, all right, plus what? Plus 64. 32 plus 62 is giving us exactly 96. Can you see that this question is making sense? So when you add it to the hydrogen given there, making 98, which is the molar mass of the acid given, because the acid given is what? H2SO4. We have come to the end of today's video. Thank you so much for watching. I wish you good luck in your exam. Make sure you follow this step-by-step procedure given in this video as you watch it, and I believe you have your way, your A. See you. Bye for now. Subscribe.